Hey guys, welcome back to the coding interview pattern. This is the fifth video in this series and we are going to cover the merge intervals in this pattern. Now its name suggests merge plus intervals. So merge is common word, like something we need to merge this. Intervals. What is intervals? Interval is something which has some start and end point. So if I say this one, let's say I am seeing this 10 and 20 and I put this in the seconds. So this become interval 10 to 20. So that means this suppose this is related to some task. That means it takes around 10 seconds, or it start at 10 and it end at the 20. So this is what is called a interval. Now this merge interval pattern is mostly used in the finding or solving the problems which are related to intersecting the intervals. It's kind of where interval are overlapping, something related to like time slot allocation, resource allocation. Such kind of problems are solved using this merge interval pattern. Now when we talk about this merge interval pattern, there can be some kind of problem where you want to merge the interval if it is overlapped. You may need to add the new interval in the existing list, or you may need to find some minimum intervals required to complete some task. So such kind of problems can come on this merge interval. Now before we go with any problem or something, let's understand how interval can overlap. So let's say this is one interval I. So this is interval I1. Now I am drawing one more interval which is I2. So this is interval I2. So these two intervals are not overlapping at all. So those are called non-overlapping intervals. Now if we change something, if I draw this up to here, that means this much area got overlapped. This area. So this is partial. So we can consider it as the partial overlapping interval. Now if it is like that, so this is completely overlapping the intervals. So intervals are completely overlapping. So with this there can be three kind of overlapping: non-overlapping at all, partial overlapping, and the complete overlapping. Now when you need to use this pattern is when the problems contain or problems when the problem is there and you give the input as the list of the intervals, and you need to play with the interval to find merge interval, find the missing intervals, or something related to resource allocation, time allocation. Maybe there are some common problem like we have few meeting rooms and we just want to make sure that there is no overlapping meeting. Or maybe there is one person to whom we are assigning tasks. We just need to make sure that he is not getting the overlapping task. So such kind of problems comes there. If it is getting the input as the list of intervals for the multiple person or one person or whatever the resource, it can be different unit or input, that we can use this merge interval pattern. Sorry. Now let's check one simple example of the merge interval. So you have given the list of the interval, you need to merge those interval so that you can avoid the overlapping duplicate intervals. So let's say you are getting this input that these are the interval. Sorry. So last is 11. Okay. So now you have been asked to merge those intervals. Here one thing is these intervals are sorted based on the start time. So if you see the start time, these are sorted. Now you need to merge the intervals. Why I say merge is there will be some overlapping. See, if we see from this 1, 2, 3. So it starts from 1, that's completed 3. Now this one it started at 2 and completed 4. So this interval was continuing at 2. That means where it start, it was not ended. Again, when this interval start, this interval was continuing. It was not reached to end point. So based on that, what condition we derive is that the start time of second interval, of the second, or you can say, let's say current interval is less than or equal to the end time of previous interval. So that means here if you consider is 2 is less than or equal to 3. 2, the start time of the current interval is less than or equal to end time of the previous interval. 2 is less than or equal to 3. This is true. That means 2 are overlapping. So this is you can apply the condition to check if that overlapping or not. Now at the next solution we may think on that, hey, we will select one interval and then again we will check against each interval in the for loop to see if anyone is overlapping it. But in that case, the time complexity of this will go off the big of n square, which is the very big. But we can achieve it with the time complexity of big O of n. So what we can do is, we have been told that, hey, give us the merged interval. That means that should be the overlapping interval, that should be your output. So let's define our output here. So output we will give the list of intervals, but that will be not overlapping it. Now to start with, what we will do is, we will see first interval, the start point is there. There is no previous interval. So start point will always remain this one. So we can put the first as it is. 1 is equal to 1 and 3. So this is the start point. Now what we will do is, you can go to the next interval. So once this is there, you go to the next interval, you apply that condition, the start of this interval is less than or equal to end of the previous interval. In this case, 2 less than or equal to 3, correct? So that means this started before this, correct? So that means what we can do is, we can update the end time of the previous interval. Now what we need to update end time is, we need to take the maximum of 2. So from this one, this is the maximum, so we assign the 4. So we say, okay, end time is, we just need to update the previous interval. Just remember, don't need to add the new one. We'll update it the 4. So it's become 1 to 4, 1 to 4, which has covered 1 to 3 also and 2 to 4 also. Okay, we'll move to the next interval from here to here. Still our previous interval is this one, because this is the we added in the output. In this one we'll compare it. Sorry. We'll say the current is 5 less than or equal to 4, which is not true. Correct? So that means this interval is not overlapping with previous one, so we can add as the new interval. So we add 5 and 7 as the new interval. Now this become a previous. This is fine. Now this is become our previous interval, and we'll move at one step. So we'll move to here. Here we can again apply condition. The start point of 7 less than or equal to 7. This is true. Now one thing I think I already told about this one is that most of the time this end time is included, or it is like something called closed. So you can consider end time as part of the interval. If somewhere explicitly mentioned to not consider this end time, then these two will not overlap, because one will complete at 6 and other or 6 or maybe 6.9. One will complete at 6.9 and what about the end time, and other will start at 7. So it's not overlapping at all. So if it not told, it's not mentioned as included chloride, you can consider it included. And in that case it is overlapping, so we can consider as we can take the maximum of these two and we can update the new closing time as the 9. So this again our the last interval was there. Now we can move to the last one. Here the start time is 10, the end time was 9, 9 less than was not there. That means this is again become new interval. We can say 10 and 11. So we have traveled through this array only once. So that means we have achieved on the big of n time complexity. With the naive solution, it was the n square. So this is output 1 to 4, 5 to 9 and 10 to 11, which is the merge interval or finally output. If you want to do coding also, you can just take the simple loop. In the one loop you can just keep track of these previous intervals and you will be able to do it. So if this is clear, let's move on to one very practical problem. So we will take one problem which is called employee free time. Employee free time. So it's kind of something also we can consider as something related to resource allocation also, like we developers have assigned some resources, like work is assigned, we just need to check any developer is free or maybe all developers are free for some meeting. So let's say for example for now we want to schedule one meeting, we just want to check it if all employees are free at some specific time so that we can schedule the meeting. Now in this case we have the data which is like employees busy time data. So it's like suppose we have two employees, employee A and employee B. We get some data. Let's say this employee is busy from 1 to 2, then let's say 2 to 4, 3, then 5 to 6, then 7 to 9. Suppose let's say he is busy. This is his data. Let's say employee B is also busy from 2 to 3. Then let's say he is busy from 6 to 8, and then again suppose 9 to 12. Okay, so this is about the data we received from as a problem statement. Now what we want to find, if you see this one, this is like, see, this is timeline. Let's say 1, 2, 3, 4, 5, 6 and like that. And we have given one employee 1 A and B. So what we are saying is that if you get the data, then this employee is busy from this one, this busy from this time, and for B is busy from this time, is busy from this time. So you should take the free time of this employee, both employees. If we consider from this one, this is the free time. That means 3 to 4 is the free time. We will not take the infinite time. So this is the time we will not take. We will not take this time. We will take from the first start and the last end time. In between, whatever we get the free time, that will be our the result. So this thing keep in mind. Second thing is, whatever data we received, it is for each employee, it is in sorted order based on the start time. So we will get the list of the data. For now, for example, we are taking the 2. It can be like 10 employees. For each, we have the sorted data based on the start time of each. Overall data is not sorted. For each list is sorted based on the start time. Now, let's see how we'll find the free time across all the employees. So to find this one, see, as I said, we will not consider the infinite time. We will consider from the starting time and the first point. So we will maintain one queue, and in this queue, let's say we define this queue here. This queue also will be sorted based on the start time of the interval. Any interval you put it will auto sort based on the start time. That is the property of this queue. In the coding we need to define that. Now at the first time we will take the first interval of each candidate. So in this queue at a time there will be one interval from each employee, maximum one. If interval is ended, there is no more interval, it can go, it's fine. But maximum there will be one interval at a time in this queue. So first time we will insert the two intervals from each employee and which will be auto sorted. So if we consider this one, this and this, and if we sort it, it will become like this: 1, 2 and 2, 3. So as of now in this queue, two intervals are there. Now we need to keep track of that one. And hey, this interval is from A and 0th index. I'm considering this as the array list or list term. And this is from the B from the 0th index. Why I'm saying this one? Because whenever we remove this one, we will add the new from the same employee. So just to keep track that hey, this was from this one, this was from this one, I'm just adding the index. Once we have this queue ready, we'll define one variable which we say, let's say it's previous. And previous, at the starting point, we will assign the start point of the first of the queue, which is the 1. So this is data is done. Now what we'll do, we'll keep comparing across this queue, keep removing, keep adding, keep changing the previous, and we'll keep deriving the result. How we'll do? Let's see it. So what we'll do, each time we'll remove this one, or we'll take one interval from the queue, which is the first interval. So for now our plan is this one, we'll take this interval. From this interval we have start point 1 and end point 2. We will compare if the start point of this one is greater than previous. That means if there is some gap, this is starting after the previous, that means this gap can be the free time of the employee. So this condition we will check it. So in this one we are checking the start point. If in our case it is 1 greater than 1, 1 greater than 1, which is wrong, so this is not there. If it was satisfied, we could have entered that as the result. We could have said, okay, there is some interval. We need to derive that interval, but there is some interval which is the free time. But in this case, this is not true, so we will proceed ahead. Then we will assign the new value to previous. In the new value, what we will do is, we will take the maximum of the previous value and the end of the current interval. So our current interval is this one, previous value is this one. So if we consider 1 and 2, maximum value is 2. So we assign the previous as the 2. This 2 is done. Previous is assigned up. The check is happened. Now, as I said, we need to keep removing this one and keep adding the new. So if we are removing from the A, we need to insert new from the A only. So in this one, this is went out. This is, we have removed it. Okay. Now it was from A0. So that means we need to take the new one also from A only, which is 2 and 3. So now let me take again. So let me take the 2 and 3. I could have put here only because see, in the queue it is again sorted based on the start time. So this again, and I have considered this also, which is A of first index. Correct? Now we will apply same formula in the same. This is again become loop now. We will check, we will take this one. Okay, let's decide one result also. What is the result? So for now it is empty. There is no result. We haven't derived any free time. We are saying we will apply start is previous. So start time of this one is 2. previous is 2 which is wrong. That means previous there is no free time till now. Second things, we'll assign the new previous. New previous will be what? Maximum of the old previous and the current end. 2 and 3, if you can consider maximum, the result will become 3. So that is 3. Assign to previous, and then we'll, okay, I forgot to end that one. Add new interval. Okay, so that means we need to add the new interval. We have removed this one, we are removing from the B, so we'll add from the B. B0 was there, so this is done, we'll add this one. Now so let me write this here. 2, 3, I'm writing it here, so you can remove from here. Index I am not maintaining because I am keep ticking here, so we'll have track that what we have added it. But in the coding we need to have the maintained index. Now we need to insert this one. If we sort it, so it will come here 6 and the 8. Let's tick mark also that this has been used. Okay. Now again we will take this one. So this was from the B and this is from the A. At least we can maintain that one. Obviously it's visible for us. It's unique interval, so it's easy for us to identify. But still we can just maintain it. So now we will take the first interval. This will consider it. So I am considering this one. 2 and 3. We'll take the start point of 2 is greater than previous 3, which is wrong, and this is not satisfying. Start greater than previous, not satisfying. So we are not deriving any result yet. We are not finding any free time yet. Assign the new previous. We'll compare the last previous and the current end. Maximum of 3 and 3, which is equivalent to 3. So previous doesn't change. Then we are saying add new interval. So we are removing from the A. So we add the new A. This we need to add it. Now if I remove this one, this is 5, 6 and this is 6, 8. That means the 5, 6 will come first because it will be auto sorted as I said. Correct? And this is again from the A. I am tick marking, this has been used. Clear? Okay, now looks like we are not going to find any free time. Let's see it. Okay, so I am taking this one, 5 and 6. Start time of 5 greater than previous time 3. Start time, okay, we are going to find since. Sorry. Okay, so start time of this one is 5, end time was 3. Correct? So that means we are finding some free time here. Now how will we find the free time? So the free time will be, so we need to find the result here. We found some free time. Free time will be the previous. So previous is 3 and start time of the current, which is the 5. So this we have derived a one interval of the free time 3 and 5. Again what? So if we get the free time here, if this one suppose if succeeds, then free time will be previous and current start. So this is again, it was the current start same. So this will be the result of the free time. So we are saying the previous equal 3 and current is 5. So we have derived one result of the free time. Once free time is done, we need to change the previous. Previous, we will take the maximum of the previous and the current end time, which is the maximum of 3 and 6, which will become 6. Add new interval. So this is done. We need to remove this one from we are removing from A, so we add from the A only. So we are removing from this one. If we add from A this 7, 9 in sorted order, it will come here 7 and 9. So that means A is done. This is A. Now we'll take this one as the current interval. In this one, start previous. So start time is 6, previous time is 6, which is wrong. That means we are not finding any free interval here. Second, assign to previous. Previous means maximum of the, so assign to previous here, just let me take it. Maximum of previous and current end. Okay, so maximum of the previous and current end, which is the become the 8. So I am saying 8. Sorry, 8 is the new previous. That is done. We are not finding any new interval. Add the new interval now. New interval we are removing from the B, so we add from the B only. So we need to insert this one 9 and 12. So it will come here as per the sorting order, which is the 9 and the 12. Correct? Fine. This is from the B. We'll check again. We'll take this current interval. Start previous, start 7 greater than 8. No, that means there is no free time here. We'll assign previous new one, maximum of the previous and the end, which is the 9. So let's assign the new time as the 9. Then add the new interval. So we'll remove this 7 from A. From the A, it is now no more intervals are left, so we will not add the new. So if there is there, we need to add it. If we reach at the end of the list, we will not add the new one. We'll go to the last loop. This is the last one now. 9 greater than 9. No, this is wrong. Previous start not greater than previous. That means there is no free interval now. Assign the new previous. We can assign the new previous. Will become the maximum of the previous and the end, which is the 12. Add to the new member. We are removing this one. There is nothing to add here because both are end. So that means Q become empty, and our final result is 3 and 5. Okay, so these steps, let's put this on the timeline. So this is a 3 and 5 result. 3 and 5 is result. So if you put this in timeline, let's say this I am drawing the timeline. It starts from 1 to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Then we draw the line. So 5, 6, 7, 8, 9, 10, 11 and this 12. If you consider A and B, A is busy from 1 to 2. So this is busy. 2 to 3 is busy. 5 to 6 he is busy. And 7 to 9 he is busy. B 2 to 3 is busy. 6 to 8 he is busy. And 9 to 12 he is busy. What is the clear free time? This is the free time, right? 3 to 5, which we derived from the result. Right? So just keep in this mind what are the steps you need to follow it and how to check this one. See, the problem can be different also. This is like employee free time. It can be like meeting scheduling, meeting room availability. There will be some twist in the problem. But if you are clear about this conceptually, how you can check the free time, how you can check the merge interval, find intersective interval. Like that, if you are clear start time, end time, some basic property, you will be able to solve any problem. In this one, just keep clear in mind that hey, you need to take the first interval of each employee first, and then when you are taking in the queue, you need to define that queue should be sorted by default. It should keep sorting it, I mean, and then just apply the start, previous, and the steps, and finally you will derive the result 3 and 5. So let's go to Eclipse and code for this one. Let's see how we can use the queue, how we can apply the steps, and finally we derive the result. We may take the same example in the Eclipse, and we will check for some more other examples also. So let's dive in the code. Okay, so we are back to the Eclipse. Let's create one class for this solution. We call it
employee free time. Okay, so we have this one. Now we'll start implementing our method. What we want is uh, our method will return uh, list of the intervals. So here I already created one class, kind of utility class. Let me show you what is that. Util interval. Okay. So this is I just created start and end point. Nothing much on this one. One is the start and one is the end. And yeah, we said this one is get employee free time interval. Okay, we'll come back to the input, what it will get. First, let's define the result. Uh, this will be result, and for now, let's put it new array list. Okay, cool. So we are just returning the result. Fine. So now on our input side, as we saw in the video, we will get the list of the employees with the list of the interval. So it is list of the list. So if I write it here, it will be the list of the list of the interval, and then you can say it as the schedule times or schedules. Now in some cases, just remember that here we are defining the interval class. Maybe there you may get the instead of the list, you may get the integer array. So if it is integer array, suppose we can consider 0th index as the start point and 1th index as the end point. So even if we have that kind of result, we can just return the list of the integer array instead of the interval class. So that doesn't make much difference, but I'm just giving you update so that you can keep in your minds that there can be input with this, then you need to solve the problem. Uh, Fair enough. So moving ahead. So what we said is this one, we got the list of the schedules. Now, if we start with this one, what we said that we will prepare the queue first. So if you remember our video, what we said that we will prepare the queue first. Queue. Or you can say also heap also, like we have used that queue, or if we maybe two heaps pattern video. What we'll do here, we will prepare the queue first. Prepare the queue. How we'll prepare the queue? We'll prepare the queue in the sorting order as per the start time of the interval, and we will take one interval from the each employee. Okay, so what we are going to, let's define is the queue first. We are on to the sorting part queue, so we'll use the priority queue. And inside that, as we said in the video, we need to maintain two, three things. We need to maintain the head. This is for which employee. This is from the which index for that employee. So to handle all those things, we need to define our priority queue as the integer array. So let's say this is queue, and once it keep moving, you will get to know more on this one, why we are using this one. Now we said that whenever we insert the data in the queue, we want it is sorted based on the start time of the each interval. Now let me come back. Okay, let me write here. I'm putting this. We are always going to put the start time as the first value, so I'm putting the A0 minus B0. I will come back here also why I put the A0 minus B0 in the sorting order. Okay, so that is fine. Now what we are doing is, we are saying we will insert one interval from each employee. By default, we will insert one interval from each employee. That means we will do what we will do. We have this first outer list. The outer list is the nothing but the list of the employees. And inside that, for each list, it's contained the list of the intervals. So if we say the schedule the size, it is nothing but the number of the employees. So we'll start with I equal to 0, I less than schedule dot size I plus plus. Okay, so that means we are iterating the outer list, which is the list of the employee. Okay, now just uh, now what we are doing is, if we get from the schedule, if we get the value at the index I, which is what we'll get it, we'll get the list of the. So let me change here integer. I just changed for the demo purpose interval. Okay, so we'll get the list of the intervals, correct? Because if I get this one, so that means I'm getting the list of interval, and this is what, this is one employee schedule. This is schedule of the one employee for that ith index, correct? So that means up to here we received or we have the employee schedule of that one employee. Now what we want? We want the start time, or we want the first interval. So what we'll do? We'll say interval, and we say, let's say here we can say first interval, because we want the first interval. So that means if we get this from here, and if we get the first value, which is the 0th index, we will get the first interval. So in this loop, we got the employee schedule. From there, we receive the first interval. Now it's our time to insert the data in the queue. Now when we are inserting the data in the queue, just let me write it first. We need the integer array, obviously, that we know we have defined what value we are going to insert it. That just pay attention to this. So we are saying we want this queue to be sorted based on the start value of each interval. So first interval dot start will be the, okay, I think I need to change the uh, values to public. Okay, so I'm saying first interval dot start as we are entering the first value. Second things, we want to know, see, we are inserting in the queue, we are inserting the start time, but we don't know this is from the which employee or which interval, right? So we need to have two things, that is the start time is there, but what this is for which employee and for which interval. So we are saying this is from the ith employee. So we got, okay, this is from the ith employee. I is the index of this one, A, B, C, D, it can be any employee. But again we are saying, okay, but for which index? Because as we saw in the video, we keep adding and removing the interval for the particular employee. If for one employee we are removing, we are adding from the same employee, and we need to make sure that, hey, we have consumed this one, we need to move to the next. So we need to maintain the index of that interval also, and for that we will insert the 0 here, because this is the first interval. We have used the get 0. So this is, hope this is clear. Once again, let me repeat it. We are saying we are getting, so for each, in the for loop, we are iterating through each employee. For each employee, for one by one, we are getting the employee schedule. From employee schedule, we are getting the first interval. See, this is, as we said in the video, it is by default sorted. Like for each employee, the intervals are sorted based on the start time. So our first, we are getting the first start time. But when we insert in the queue, we need to also tell them that, hey, this is from the which, it's A or B, which employee. You remember we were keeping the, in the board, we were keeping the A, B, we will just keep assigning just for, because this was the drawing, so we can handle in different way. Here in the coding, we need to handle in the different way. So here we are putting the, that this is the employee A, B, whatever. And then we are saying, okay, this is the employee A and this is the 0th index or first or second or third interval. Now coming back to this, I was saying about sorting part. We are sorting based on the first value because our first value is the starting point. Now we have result. This also we have defined. Now, as we know, we need to define one previous variable which will keep the last start time, or maybe it will keep changing it, but initially we need to keep the first start time of the interval from the queue. So if you remember from the whiteboard, we need to take the first value from the interval of the queue, which will be the queue dot pick, and we will take the first one, which is the index 0. So why we are taking first? Because we inserted the first at the start time, so we are saying index 0, and pick, it will always give the first value as per the queue. So we have the previous value, we have defined this as. Now we just need to keep checking that iteration we were doing it in the loop, we need to do that one. Now until what we do is, we will do till we have the data in the queue. Simple. Okay. So we'll do this one till our queue is not empty. Okay. Till queue is not empty, we will do these things. Okay, fine. Now what we were doing in this one, if you remember, we were checking the steps. As per that, we were checking the start and previous time. Start and previous time. We are comparing start and previous time, and if it is matching that to what we want the result, then we were checking the we were adding as the result, and then we were uh, evaluating new previous value. Okay, then adding new interval in the queue. We are doing this many steps. So starting with previous, comparing the starting and comparing the time. What we need first? We need the first interval data from the queue. So what we'll do for that? We will say, let's say we have this, what we have the integer array here. So we'll define the integer array, and what we call it, let's say this is the one entry, or queue entry you can say it. Okay, so it's, don't consider that like same as the map entry. I'm just giving this name, so it will be uh, easy to remember. Okay, so we are taking the queued entry and we are taking this one. What we'll do it? We will do queue dot full. Okay, so we took the first entry out from the queue. It means we removed this one. As we know that we're removing the entry, we are adding entry. So we removed this one. We will have the from which candidate we have removed also. So we'll know that which candidate to enter it. So we have the candidate index. I can say it because we want to insert from that candidate. So candidate index is nothing but what? It is first index. Remember, we entered the I as the first value. Correct. And what we need is that interval index. Interval index is nothing but 2, because see, first time we inserted 0, so it was the 0th index. So for that candidate it is the 0th index. So it is the if we say interval index, this is for that specific candidate. So I'm saying for the candidate this index, this is the interval index. Okay, so we have found this also. Cool. Now what we are doing is, we are saying for this, we get the interval for this one. We have both candidate index and the interval index. So we are saying we have the schedules. We have schedules. We are saying get. What we do? We'll say candidate index. Then we'll say get. What we'll say? We will say the interval index. So we got the both interval and candidate, and we got the exact interval. Okay. Now once we have this data, we will compare this start, previous time, and this one. So what we say, if this interval start time is greater than previous. Remember what we are doing is the borders, we are doing the interview start time greater than previous time. That means we found some free time, and we will add the free time in the result. Okay, so we'll add the result, the free time. But what will add it? We need to have the new interval. What is the start time and end time for this one in our new interval? Remember, we were saying it is the previous time to this interval start time. So previous time and up to this interval start time is nothing but the employee free time. So we have received the result. Okay, this is done. We added the result. If we find it, we'll add it. If not find, we'll skip that step. I mean, like if condition, we'll skip that. So on this one, once we have done this one, we need to, it's time to define the change the value of the previous. So in the previous, what we said is we will take the maximum value of previous and the current intervals and time. So that means we'll take the math.max of what? Previous and this current interval what we are there, this end time. So end time, it can be end, it can be time or whatever, but we are saying end. Okay. So we got the previous as the maximum of the previous and the interval end. This is done. Now what we'll do? We will add the new value. So that means we will see we have removed for this candidate index. We already removed this interval index. That means in the from the queue for this candidate interval got removed. So we need to add the new interval. But that interval will be which one? That interval will be the interval index plus 1. Okay. So we are saying this we need to add the interval which will be the next interval. But we need to make sure that hey, in that candidate there are some interval left. We shouldn't keep adding it, it's go out of index exception, right? So we need to say that okay, this is the current index. And if I do plus 1, and if it is less than my schedule dot get candidate index. So I'm saying for that candidate, what is the size? Okay, it's say we are saying interval index plus 1. This is the less than that candidate's index. That means there are some interval left for that candidate. We can insert it. If this is there, let's get the interval. So what we get? How we'll get the interval? Okay, so we'll get the interval here. Let me define here. Interval, new interval. What will get the new interval? We will say for this from the schedule, we'll say that first get the candidate. So we say candidate index and then get the interval. An interval will be nothing but current interval index plus 1 step ahead. So that means plus 1. So we received a new interval. Now we need to insert this interval in the queue. So in the queue, we will say okay, offer new value. The first value always will be the interval start value that we know. So we need to define the new integer. Yeah. So first value will be interval dot start. So new interval. What was the second value? Second value was nothing but the candidate index. If you remember, we inserted I, which is nothing but candidate index, and we took back same thing, candidate index. So we are inserting the candidate index, the second value. What was the third value? We inserted 0 because this was the fixed for loop. We know that for each candidate we are taking the one interval which will be 0th index. Now here, if keep increasing, last time it was 0 was there, so that means it is will be interval index plus 1. So suppose in the first one it may be the first index, but it will keep changing it. So every time what we are doing, we are increasing one index for that interval. And we have inserted this new interval dot start, candidate index and interval index plus 1. So we are checking this one. If there some value exists for the candidate, then insert it, and again we'll follow the same step in a loop. So that's it on the code side. First, I think hope it's clear. Let me go through it again. We'll get the list of interval which is scheduled. We'll create the one queue which will be the priority queue to keep sorted according to the start time. We insert the start time, but with the start time we need to maintain the candidate and the interval index so that we will insert the two extra values. This is the fixed loop we are doing over the outer list. That means for the list of the employees. So we are just adding the employee index and we are considering the interval index as the 0 because it is always the first interval. Then we are taking the previous as the first value from the queue, and then for each interval we get the candidate index, interval index. We compare the start time, previous time. If you find that this is the free time, we insert in the result. Then we just define the previous value. Then if we see that for this candidate we have removed one interval, let's see if that still exists. If it exists, then we'll insert the new interval in the queue. Okay, so it's time to check it. Let's see how it works. So what we'll get in the return is we'll get the interval. Okay, and we'll say get employee free time. We need to have the schedule time. Now on the schedule time, we need to define the schedule. Let's define outside. So it will is to maintain list of interval. Okay, and that is schedules. Now we need to define this schedule. So I'm putting arrays as list, and then we will insert the array integer. So what we'll do is we need to insert the interval in the list of the interval for each one. So if I do this one time, I need to have 1, but I need to put the 2 time because they have the 2 1. So I'm putting the, let me put here. No, okay, I'm putting the one list for this first one, suppose, and then second. Okay, so I have the 2 employees. Now for each employee, let's insert some data. So what we need to insert? New interval. We have the start and time, new interval, and let's keep as per what we kept in the video, and then we'll keep changing the value. So it was, let me insert some data first and then we'll change the value. Sorry. Okay, let me copy this only and paste in the bin second line. Okay, so now what we want the start and end time. So it was 1 and 2, it was 2 and 3, then it was 5 and 6, and it was 7 and 9. 7 and 9. Let's prepare the same for second also. Second 2 3, then 6 8, then say 9 12. 9 and 12. Okay, let's remove this one, we don't need in this moment. Okay, okay, so this is the result, we get it, right? Okay, so we are passing this one, we get the result. What we need to do it? We need to print the result also, right? For okay, so for result we are saying for each interval system dot out dot. Okay, so what we'll do, we'll print something like printing as interval, and inside that what will be there, we will have the interval dot start. Okay, then we need to put comma. Okay, I think, and then we need to put interval dot end, and I think that's enough. I hope. Okay, So let's run this program and see. If we have some issues, we can try to fix it. Okay, 3 and 5, exactly what we saw in the video, right? I think, yeah, it was 3 and 5. Now let's keep some changing the value. So we are saying 3 and 5 is there. So first candidate is available from, okay, let's say make some available more candidates. So let's say if you just increase some value. So 9 to 12 was there. Uh, and then, okay, let's say 13 to 15. Let's enter some value here also. Okay, let's say this is also 14 to 18. Some mistakes in, no, sorry. Okay, so I think now one more time will be available. Let's see. So 12 to 13 it's said. Why we say 12 13? Because 9 to 12 is there. Then 12 to 30 for this one is available. He is available 9 to 14, but for this 9 to 12, so this is 5. So yeah, you can check with the more input answer test cases. We also may need to handle some cases where suppose this is coming empty, or there, let's say some edge cases you can handle it. You can think on more edge cases also and see that where it can fail it. So just think on such cases. Yeah guys, I think that's it on this video. You can try from your side and see how it looks. Yeah, if I say about the time complexity, see on this one we have the number of employees. uh, so let's say if we take the number of employee as n, so we say as the number of employee, and let's say k is the number of total intervals. So if we consider both, and we are using the queue also, and that's getting sorted, right? Every time we insert, it's getting sorted. That is the main. It's consuming the time complexity. Other than this one, while loop we are doing for maximum n time, because for n time it will have the n interval. I'm saying every time we add one and we remove one, so maximum n time it can go it. But this sorting will consume little time complexity. So with that, if we consider n is the number of the employee and k is the number of intervals, then time complexity will go as k of log of n, where n is the number of employee and k is the number of intervals. On the space complexity side, it's big of k, because we are inserting all the number of sorry, not number of intervals. No, number of interval. I said number of employees n. Okay. So see why we are saying. So I would say first I added k, number of intervals. But if you remember in the queue, at at any moment maximum we are keeping one interval per employee. So we added first time one for each one. Then here each time we remove one and add one. So at maximum it will be there the number of employee that will be the interval inside this one. So it will be the big O of n. Okay. So that's it, guys. On this one, you can try to solve some more problems. There are something like um, there are like task scheduler related some problem you'll find in Google. You can try to apply such pattern and see it. We'll meet in the next video. Thank you for watching.